Greetings to every one of you. So in this video we are going to discuss another very important concept from operating system. It is a round robin scheduling. It is a preemptive type of scheduling. It means the process may be removed from the processor forcibly before its time of completion. Actually, this kind of technique, it is highly used in time sharing and multitasking operating systems. This technique is very much similar with first come first serve scheduling, but with a small change, like the introduction of a concept called fixed time quantum or fixed time slice is used in this algorithm. So based on the arrival time of the processes, they are added into the ready queue and sent for execution for a particular the fixed amount of time quantum. Then here we have to check any new processes arrived during that period of time quantum. If yes, those processes should be added into the ready queue. Check if there is remaining burst time of that current process, then we have to add that process into the ready queue. Here we are using a data structure, it is circular queue to implement this scheduling policy. The context switching is another technique that is used in this method that we will discuss later. The problem is given here. We have to solve this problem. I have to find out the completion time of each process, how to calculate this turnaround time, the waiting time, the response time. So that actually we are going to do now. So initially we have to check the arrival time of the processes. So which process that is enter first. So at time 0, process 1 that is enters at time 0. So once it is added in the ready queue, the process will be transferred to the execution queue or the processor for execution. So the time quantum that is used in this problem, it is 3 milliseconds. So the process 1 will be executed for 3 milliseconds, so 0 to 3. So now here it stop execution. So during this time, we have to check that any other processes are entered. So actually 0 to 3, actually at time 2 and 3 we got 2 processes. So these 2 processes should be entered. So that should be added into the ready queue. Okay. So that is process 2 and process 3 that is entered during this time quantum. Okay. So that is what I said. During this time quantum, if any there is new processes entered, that should be added into the ready queue. Now the process 1 actually that is over, and now we have to load the process 2. But the process 1, it has completed only 3 milliseconds of its time. So it has the remaining burst time. So that has to be complete. So what you have to do, the remaining burst time, if the current process it has the remaining burst time, again you have to store it in the ready queue. So what you have to do, after this P2, P3, you have to store this P1 also in the ready queue. Okay. So now the P2 is under execution. So again for P2 also only the 3 milliseconds of time will be provided. So at millisecond, at a 6th millisecond, the P2 is what is that? It is also that is completed 3 milliseconds of time. So what happens, that is again it has remaining time of 3 milliseconds. But during that time, that is 3 to 6, we have to check that any other process that is arrived. So we can see that the process P4 arrived at 4th milliseconds. Okay, so P4 it is arrived. So that should be that is added here. But here again this P2, you know, it has the remaining burst time. So what you have to do, you have to add this P2 in the ready list. Okay, so now get the next process, that is P3. Okay, so P3 require 3 milliseconds of time. So at 9 the P3 is get over. So the remaining burst time for P3 is 0 only. Okay, so now we have to get the next process. So that is P1. So P1 is loaded. So P1 will take another 3 milliseconds. So it is 12. Okay, so 3 milliseconds that is provided for. So again it needs one more 1 milliseconds more. So what you have to do, you have to check any other new process arrived during this period. If there is no process arrived, okay, so we can leave it. Now you have to store this P1 again in the ready queue. Okay, so now get the next process, that is P4. So P4 requires only 2 milliseconds of time. So by this is 12, by 14 it is get over. Okay, 2 milliseconds of time is required. So this is 9 plus 3, that is 12. Here we have we need only 2 milliseconds of time. So that is 14, it is over. So now you have to, according to the given list, ready list, the next process is P2. So P2, it needs it needs only 3 more milliseconds. So that is get over by here. Okay, now the remaining time for P2 is 0. So P2 is over. Okay, P2 is over. So now we are loading this the next one, P2 is also over. Now we are loading the P1 which require only 1 milliseconds of time. So P1 is also, that is over. So here actually at the time of stopping one process and loading the next process, here the operating system, it performs an operation what is called the context switching. So the context switching is save the status of the running process in the process control block, brings the new process. So actually at this point the P1 is what is that? It is removed from the processor and P2 is get loaded. Okay, so this is what is called the context switching. So why actually we are storing this the status? Because the next after some time again we have to load this P1. Okay, so after loading P1, this execution will be continued after that what the portion actually the left out, that will be continued from here. Okay, so because of that particular reason, this context switching is what's that used in this scheduling algorithm. Okay, so now it is over. Now we have to do our calculation. What is the completion time of the process 1? So right from here you can just go through the Gantt chart. For P1 the finishing time is 18. Okay, similarly for P2 it is 17. Similarly for P3 it is 9. For P4 it is 14. Okay, so how to calculate this turnaround time? Turnaround time is completion time, then minus arrival time. So it is turnaround time, it is 18. It is 17 minus 2, it is 15. This is 9 minus 3, it is 6. 14 minus 4, it is 10. Now we have to calculate the waiting time. So the waiting time can be calculated as turnaround time minus the burst time. So turnaround time is, so you have to take the original burst time. Okay, 18 minus 7, it is 11. Then 15 minus 6, it is 9. Okay, then 6 minus 3, it is 3. It is 10 minus 2, it is 8. Then how to calculate this response time? So the response time can be calculated from the starting time of the process minus the arrival time. So here we can see that what is the starting time of the process for P1. The very first time it is assigned, it get the processor. So that is the starting time. So starting time of process 1, it is 0. So what is the arrival time? It is 0. So 0 minus 0, that is 0. Okay. So similarly for the starting time of process 2, it is 3. 3 minus 2, it is 1. Similarly, what about process 3? The starting time of process 3, it is 6. 6 minus 3, it is 3. Similarly, for P4, the starting time is 12. So 12 minus 4, it is 8. So what actually you are given here? It is turnaround time, so waiting time and response time. So for all these things, we can calculate the average turnaround time, average waiting time. So for example, average turnaround time is equal to, for sigma I is equal to 1 to n Ti by n. So this total value, it is 49, turnaround time it is 49, 49 by 4, this n is nothing but number of the processes, n is number of processes, so it is 12.25 milliseconds. So similarly for the waiting time, average waiting time can be calculated, that is Wi by n, it is equal to, that is 31 divided by 4, it is 7.75 milliseconds. So similarly we can calculate the average response time, it is 1 to n Ri divided by n, it is 12 by 4, it's nothing but 3 milliseconds. So we have discussed about this round robin technique. So it is a primitive type, and I said it is very much similar with the first come first serve algorithm, with a small difference. Suppose if you increase this time slice, see for example, if I increase this time slice to, that is 10 or 20, so what will happen? This just it will act like first come first serve algorithm. If this time quantum value is greater than the burst time, simply it will act like a first come first serve algorithm. So that is one important point that you have to remember. The data structure that is used in the scheduling policy, it is nothing but the circular queue, and also that is how to calculate this completion time and turnaround time, their the response time and their average. Okay, I hope you understood the concept. Thank you.